Welcome to lesson 7.5, proofs on the coordinate plane part 2. You might remember from the last lesson we were proving that quadrilaterals were parallelograms and rhombuses, and if you're thinking, what's this lesson about? Well, I'll tell you. It's about proving that quadrilaterals are rectangles and squares. Those are the two missing guys that we haven't done yet. Alright, so we're going to start with proving that quadrilateral is a rectangle, and it's just like the last lesson, so hopefully you haven't forgotten everything. And to do it, you're just going to do it in two steps. The first step is to prove that it's a parallelogram. Remember, it's like that with a rhombus as well. The first step is to prove that it's a parallelogram. Once that you've established it's a parallelogram by showing that opposite sides are parallel, you're going to do step 2, which is you're going to prove that it's a rectangle now by showing the diagonals are congruent. Now I know what you're asking. How are you going to show that the diagonals are congruent? These guys, the diagonals right here are congruent. How could you do that? Well, we're going to use our friend called the distance formula. And the distance formula tells you how long something is. So we're going to find the length of AC and DB. And if they are congruent, then we know it's a rectangle because that is a property of rectangles. Alright? So let's just quickly kind of go through how this will go down. So if we want to prove that this guy, ABCD, is a rectangle, first we're going to prove that it's a parallelogram. Right? So we need the slope of AB first, and then the slope of DC. And you might remember, you could just count it or use the slope formula, but I'll tell you, if you count, you'll get negative 4 over 8, which reduces to negative a half. And guess what? If you do it for DC, you get the same exact answer. Alright, so that's negative a half. Now if you find the slopes of AD and BC, well, you're going to get, I'll tell you, it's 4 over 2, it's going to be 4 over 2, which is 2. And the same thing for BC is also going to be 4 over 2, which is 2. These are all the slopes. 1, 2, 3, 4, 1, 2. That's for all the non-believers. Now you've shown that the opposite sides are parallel, so we know it's a parallelogram. So we're going to write a conclusion now, because we always write our conclusions. We know that AB is parallel to DC, and we also know AD is parallel to BC. Therefore, ABCD is a parallelogram because opposite sides are parallel. And I want to remind you guys that you see all this nice sentences that I've established for you. You need to learn to write this by yourself, okay? This is just to get you going. But you should always justify your work and write a conclusion, right? So you know it's a parallelogram because opposite sides are parallel, and you showed all your work. Now we're going to show that it's a rectangle by showing that the diagonals are congruent. Remember, we know that if the diagonals are congruent, then it is a rectangle. That's from 7.3. Alright, but how are we going to show the diagonals are congruent? Well, we're going to use our friend called the distance formula. So we're going to find the distance from A to C, and then we're going to find the distance from D to B. And if those distances are the same, that means that their lengths are the same, so they must be congruent. So I'm not going to go through this pretty quickly because there's another example we're going to do. But let me just quickly show you how you'd find the distance from A to C to find the length of it. Well, you plug into the formula, the D is equal to negative 3 minus positive 3. Those are our x values, negative 3 minus 3. Alright, and then we're going to do our y values. Well, A is 5, so it's going to be 5 minus, let's see, and C is negative 3. See? Negative 3. Alright, if you do the math here, you get negative 6, the square root of negative 6 squared plus positive 8 squared, which gives you 36 plus 64. Well, we're running out of space here, which gives you the square root of 100, which is 10. Alright, so now that you found the length of AC, you do the same thing for BD. And I'm going to save you the work right here, but if you do plug in, you also get 10. Since you know the two diagonals are congruent, in parallelogram ABCD, we know AC is congruent to DB. So we're going to write a conclusion. That means it's a rectangle because diagonals are congruent. Alright, so you see the work we did there? the first thing we did was we proved that it's a parallelogram. Then we use a distance formula to show that the diagonals are congruent. Those are the two steps, and don't forget to write your conclusions. So let's try this again one more time just to make sure we have it. We're going to prove that quadrilateral with vertices G, H, I, J is a rectangle. All right? So first, let's graph our points. We got 1, 1 for G. We got 5, 3 for H. We got 4, 5 for I. And we got 0, 3 for our J. All right? And we're going to connect those, and we get ourselves this guy, which absolutely looks like a rectangle, but that's not enough. We can't just say it looks like a rectangle. We actually got to go through all the steps. So usually I would show you how to find all the slopes. But since you did that in your last lesson, what I'd like you to do is pause the video and find the slopes of G, H, I, and J. All right? Find all those slopes and fill them in and meet me back here. So pause the video now. All right, hopefully you used the slope formula to find all of these slopes. If you did it correctly, you should have gotten the following slopes. Ji had a slope of positive 1/2, and GH also had a slope of 1/2. All right, if you did these correctly. Using the slope formula or counting, it doesn't matter. JG had a slope of -2, and IH also had a slope of -2. And after you found all the slopes, you wrote your conclusion, right? And this is blank, so you gotta be able to write it yourself. In parallelogram, and I'm just going to use parallelogram, GHIJ, JI is parallel to GH, and JG is parallel to IH. Therefore, for GHIJ is a parallelogram because opposite sides are parallel. Now we're not done. We just established it's a parallelogram. Now we're going to show that it is a rectangle by showing the diagonals are congruent. All right, so the way we're going to do it is by using the distance formula to find the length of JH, which is our first diagonal. And then we're going to use this formula to find the distance to G to I. All right, so first let's start with JH. And it'll be helpful if we write down both those coordinates. So J, the coordinate is 0, 3, and H, the coordinate is 5, 3. All right, you can just look at the top of your paper to see that. We're going to plug this into our distance formula. So the distance is equal to the square root of x1 minus x2, so that's 0 minus 5 squared, plus y1, which is 3, minus y2, so it's 3 minus 3 squared. If you put this in, you should get, well, 0 minus 5 is -5, so I'm going to move up here for a second. The distance is equal to 5 squared, or -5 squared, plus 3 minus 3 is 0 squared. So let's keep simplifying. The distance is equal to -5 squared is 25, 0 squared is 0, so it's just the square root of 25, and so the square root of 25 is 5. So JH is 5. That is our length of JH. Let's try for GI now. Let's write down our coordinates. G is 1, 1, and I is 4, 5. Let's plug that into the distance formula. So the distance is equal to the square root of x1 minus x2, so that's 1 minus 4 squared, plus y1 minus y2, so that's 1 minus 5 squared. All right, so let's see what we get here. So this is going to be the distance of -3 squared, 1 minus 4 is -3, plus 1 minus 5 is -4. What is going on? I'm running out of room here. Come on, let's go. Let's move down a little. This is 1, so plus 1 minus 5 is -4 squared. Negative 3 squared is 9. You should always get a positive. And negative 4 squared is 16. That's the distance of the square root of 25. And the square root of 25 is also 5. So we've shown that J, H, and G, I are congruent. So now we can write our conclusion. In parallelogram ABC, hold on. I gotta edit these things for sure. Let's try this again. In parallelogram GHIJ, we know that JH is congruent to GI. Those are our diagonals. Therefore, GHIJ is a rectangle because diagonals are congruent. And we've just done our proof. All right? So you're going to need to memorize the distance formula if you're going to be able to prove anything as a rectangle. So don't forget it. You need to write your conclusions as well. Let's go into a square. To prove a quadrilateral is a square, you're going to have to do a lot of work. I'm not going to lie. Because you have to show that it has 3 properties. All right? Not just 2, but 3. The first one is that you have to show that it's a parallelogram. All right? That's step 1. How do we do that? Well, we have to show that opposite sides are parallel. So we're going to need the slope formula. Right? The next one, we're going to show that diagonals are perpendicular. All right? So that shows that it's a rhombus. All right? So it has one property of a rhombus, and once again, you need the slope formula. And then finally, you're going to show diagonals are congruent, showing that it's a rectangle. And remember, a square is just a parallelogram with one rhombus property and one rectangle property. And you're going to do just what you did here, and you're going to use the distance formula to show that the diagonals are congruent. All right? And once you've shown these 3 things, that proves that it's a square. So you have to show that it's a parallelogram. All right? So you're going to show the opposite sides are parallel. That's the slope formula. Then you're going to show the diagonals are perpendicular. That's our diagonals right here, by once again using the slope formula. And then you're going to use the distance formula to show the diagonals are congruent. And once you've done all 3 things, you know it's a square. So I'm going to kind of quickly go through this one, all right? And you're going to do it by yourself a little bit. So what I'd like to do is first, all right, I'm just going to guide you. First, I'd like you to plot these, J, K, L, M, and find the slopes of all the sides to prove that's a parallelogram. So start there, pause the video, and do that. All right, hopefully you actually paused the video and you did as said. You graphed it, and then you found the slope of all the sides. You should have gotten it. -1 for JK, -1 for LM, 1 for KL, and 1 for JM. And then wrote your conclusion in quadrilateral JKLM. JK is parallel to LM, and KL is parallel to JM. Therefore, JKLM is a parallelogram because opposite sides are parallel. You did step 1. Then step 2, we're going to move on. We're going to show that the diagonals are perpendicular. This shows that it's a rhombus. So diagonal 1 and diagonal 2. Now this is going to get a little nutty, and I'll show you why. If you find the slope of KL, remember you can use the slope. So the slope of JL, which is right here, you're going to find it's up 0 over 1, 2, 3, 4, 5, 6. So it's 0 over 6, which is just 0. The slope of MK is just down 1, 2, 3, 4, 5, 6. It's down 6 over 0. All right? Which is also undefined. That's not 0, that's undefined. But before we even simplify this, you'll see that 0 over 6 and never 6 over 0, those are perpendicular to each other. So even though it's 0 and undefined, which is crazy, we know that these are perpendicular. So we know that parallelogram JKLM, JL is perpendicular to KM, therefore it is a rhombus because diagonals are perpendicular. All right, so step 2, done. You have to find the slope of the 2 diagonals. All right, find the slopes of the sides, find the slopes of diagonals, write a conclusion, and then finally we're going to do our final conclusion by showing the distance of these 2 and finding the length. And you know what? You're going to have to do it yourself. So what I'd like you to do is pause the video and find those links. All right, pause it now. Find the length of JL and KM. If you found your slopes correctly, you should have found out that JL, not slopes, the distances. You found the distance from J to K is 6, and the distance from K to M is 6. This means that my diagonals are congruent. All right, so we use the distance formula, and we know in parallelogram, JL is congruent to KM, and therefore ABC is a rectangle because diagonals are congruent. All right, once you've done these three things, you can finally show that it is a square, and you have to write your own conclusion. I'm not doing it here for you. There's no space for it. I'd like you to figure out, what would you say to prove that this is a square based on the three things? All right, I'll give you a sentence starter, but you should write it out yourself. JKLM is a square because, and I leave the rest to you. All right, so remember, it's a lot of work to do a square, but I believe you got it in you. Good luck, and you've got this.